Frank, some people talk about mathematics being the ultimate reality and everything else is derived from that. Do you agree with it?
No, I disagree. I think that physics is the ultimate reality and mathematics is derived from physics. Now, we can see that because most mathematicians want to base all of mathematics on the properties of the whole numbers, 1, 2, 3, and 4. They require, for example, a legitimate mathematic proof has a finite number of steps. Finite means that you can find a whole number which will list the total number of steps. They then derive the whole of mathematics from these whole numbers. As a physicist, I ask the question, where do the whole numbers come from? Why do we think that whole numbers are fundamental? Well, where do whole numbers come from? They come ultimately from discrete states of atoms. Now, in a different type of universe, these atoms need not have discrete states. They need not be describable in terms of these whole numbers. The underlying equations which describe these atoms are equations based on continuous variables, an uncountable number of points rather than the whole numbers. What physics is telling me is that these integers, these whole numbers, which mathematicians like to base all of mathematical reality on, ultimately are coming from the particular type of physical universe in which our laws are being applied to.
Does that mean that mathematics, as good as it is only an approximation of reality?
Mathematics, I think, is, at least in the limited parts we've been able to consider, consistent. But I think that mathematics, as we humans derive it, ultimately come from the particular physical universe we human mathematicians find ourselves in. I could imagine a mathematician in a universe which is a continuous universe without these integers regarded as fundamental. It would never occur to him that Gödel's theorem would be a limitation on mathematics. We can prove that arithmetic, for example, is consistent if we allow a more general type of mathematical proof based on letting an infinite number of steps be in the proof.
And that's the difference between discrete requirement of integers
exactly.
and an infinite number of,
yes.
of which is irrational numbers.
Yes, yes. So we can imagine a completely different type of mathematics. We can't do this because we have a finite number of possible mental states. We can only write down a finite number of symbols which we can distinguish. Ultimately, that limitation on us comes from the particular type of physical law we find ourselves in. We can imagine a completely different type of mathematics based on the continuum. We cannot construct such a mathematics.